Voyager probe has entered interstellar space, that place between the stars. It's now out beyond the sun's heliosphere.
Voyager 1, the most distant human-made object from Earth, has once again stunned scientists with an unprecedented event in the uncharted territories of deep space. More than 14 billion miles from home, this aging spacecraft, launched in 1977, encountered a strange and powerful phenomenon that challenges long-held assumptions about the structure and behavior of the interstellar medium. For decades, Voyager 1 has been steadily transmitting invaluable data back to Earth, even as its systems degrade and its power dwindles. Yet, against all odds, it has now made what researchers are calling an impossible encounter, one that defies expectations and redefines our understanding of the cosmos. Before we start, smash the like and subscribe buttons for more updates. The event unfolded silently in the void, without warning. Voyager 1, drifting through interstellar space beyond the heliopause, the outermost edge of the solar system's influence, recorded a sudden and dramatic burst of low-frequency electromagnetic waves. These emissions didn't resemble anything detected before. They weren't solar in origin, nor did they match the background noise of cosmic rays or known interstellar turbulence. Instead, they appeared to arise from a highly localized, energetic event, a sort of spacequake rippling through a region thought to be largely placid. For decades, scientists had modeled interstellar space as cold, quiet, and sparse, an endless, near-uniform expanse. Yet Voyager's new data reveals a localized zone of extreme activity, one completely out of step with predictions. The instruments aboard Voyager 1, though limited in aging, are finely tuned to capture the tiniest perturbations in their environment. What they detected was an abrupt, coherent oscillation that endured far longer than any known phenomenon of its kind. For over 12 hours, the spacecraft recorded a consistent pulse, like a beacon, emanating from a seemingly empty region of space. The signal was not just persistent, but sharply structured, with a rhythmic precision that bore no resemblance to random background noise. Scientists pored over the data, initially suspecting some malfunction or data corruption. But the integrity of the signal held firm, forcing a re-evaluation of the models used to describe the interstellar frontier. What makes this encounter so extraordinary is not just the presence of the anomaly, but its precise location. Voyager 1 is situated in a region previously considered to be free of complex electromagnetic dynamics. According to prevailing theories, beyond the heliopause, the influence of the Sun is minimal, and the spacecraft should only encounter a diffuse sea of particles and fields shaped slowly by the galaxy's magnetic scaffolding. Yet the intensity and structure of this pulse suggested a localized disturbance in the fabric of space itself. Some theorists propose that Voyager may have passed through a microshock, a compressed energetic front in the interstellar medium, perhaps caused by the interaction of galactic magnetic fields. Others speculate the spacecraft may have encountered an exotic structure such as a plasmoid or interstellar filament, formed through processes yet unknown. Adding to the intrigue is the possibility that this event might represent a rare moment where two interstellar phenomena intersected. One hypothesis suggests that Voyager the 1st of May have entered a collision zone between two different regions of the galactic magnetic field, creating a sort of electromagnetic storm. In such a zone, magnetic reconnection could suddenly release massive amounts of energy, resulting in bursts of radio waves, something like a space-based lightning storm on a cosmic scale. If this is the case, Voyager 1 has provided humanity with a first-hand recording of a process only theorized in computer models until now. But there is another layer to the mystery that makes this encounter all the more profound. The frequency and rhythm of the signal Voyager recorded bore a striking resemblance to patterns observed in fast radio bursts (FRBs), powerful millisecond-long flashes of radio waves that astronomers detect from far beyond our galaxy. FRBs have confounded scientists since their discovery, with potential sources ranging from neutron star collisions to speculative notions involving alien technology. While Voyager did not detect an FRB in the traditional sense, the structure of the emissions mirrored some characteristics of those enigmatic signals. This similarity has ignited discussions about whether Voyager may have stumbled upon a miniature version of the same phenomenon, originating not in deep extragalactic space, but right here within the Milky Way's interstellar terrain. There is also a growing debate about the source of energy required to produce such a signal in what should be an energy-poor environment. Interstellar space is not empty, but it is far less energetic than regions within the solar system or the core of the galaxy. So how did a coherent, powerful signal emerge from such a quiet zone? Some physicists now suggest that dark plasma, a theoretical non-luminous form of matter interacting only weakly with electromagnetic forces, could be involved. If Voyager passed through a pocket of such material, it might have triggered a burst of radiation via processes yet to be understood. This encounter could then represent the first indirect detection of exotic interstellar matter, something long theorized but never observed. Alternatively, the event may reveal something more fundamental about the structure of space-time itself. Certain advanced models of the universe suggest that interstellar space is not a homogeneous vacuum, but rather a dynamic lattice of quantum fluctuations. These fluctuations could occasionally coalesce into temporary anomalies, eddies or whirlpools in the fabric of the void. Voyager 1, with its unique trajectory and slow drift, may have passed through one such disturbance. This interpretation pushes the boundaries of current physics, but it would explain the structured, transient nature of the pulse. If true, then Voyager has inadvertently become a probe not just of space, but of space-time, grazing the edges of phenomena we currently lack the vocabulary to fully describe. The timing of this event adds another layer of drama. Voyager 1 is near the end of its functional life. With its power supply fading, its instruments are being shut down one by one. Engineers at NASA have been managing the spacecraft's diminishing energy by selectively turning off systems and rotating power among its various components. To have captured such a groundbreaking event at this late stage is nothing short of miraculous. It's as if the spacecraft, silent and alone in the void, offered up one final secret before fading into darkness. This encounter also reaffirms Voyager's unique position in human history. No other machine has traveled so far or endured so long. The data it sends back must travel over 21 billion kilometers and takes nearly a full day to reach Earth. Every bit of information comes at a cost, carried through the interstellar void on a whisper of energy. Yet from that whisper, we've now heard a signal that could rewrite fundamental assumptions about the galaxy's unseen forces. It's a humbling reminder of the scale of our ignorance and the astonishing reach of human curiosity. While the signal has since faded, the data remains, and researchers are only just beginning to unpack its implications. Advanced simulations are now being run to replicate the conditions that Voyager encountered. Meanwhile, theorists are re-examining older data from both Voyager 1 and Voyager 2 to see if similar but previously overlooked patterns might have occurred. There is hope that some of the newer deep space missions, like the interstellar probe concept or even telescopes, like the Square Kilometer Array, might eventually follow up on this discovery with more specialized instrumentation. The nature of this encounter forces a reconsideration of how we understand deep space. For years, the frontier beyond the heliopause was imagined as a calm, even dull domain, a place of great scientific interest to be sure, but not one where surprises lurked. Voyager 1 has shattered that illusion. Instead, interstellar space now appears more like a deep ocean, filled with currents, eddies, and sudden storms. A dynamic and reactive environment capable of unexpected and even violent behavior. This changes not only how we model space travel, but also how we conceptualize our place in the galaxy. From a broader perspective, the event Voyager recorded emphasizes the need for a new generation of interstellar probes. As visionary as Voyager 1 was for its time, it was never built for this level of exploration. It lacks high-resolution sensors and advanced shielding, and its communication systems are primitive by today's standards. Yet it succeeded where no other mission has dared to go. Now, with its unexpected discovery, there is a renewed urgency to send better-equipped successors into the interstellar medium. The possibility that similar events are happening frequently, undetected simply because no instrument is there to listen, is both tantalizing and frustrating. Beyond its scientific impact, Voyager 1's impossible encounter captures the imagination in a way few other events can. It's a story not just of data and discovery, but of endurance, perseverance, and the quiet, almost spiritual sense of touching the unknown. A human-made object, no bigger than a small car, has drifted farther from home than any explorer in history, and in doing so, brushed against something inexplicable. In the vast silence of space, it found a voice, a pulse from the void, and carried it back across the darkness to our waiting ears. As scientists pore over the data and debate its origins, one thing is clear: the universe is far more dynamic, strange, and alive than we imagined. Voyager 1, on the edge of darkness, has once again reminded us that the frontier is not quiet, not finished, not mapped. It is alive with mystery, humming with energy, and full of wonders yet to be seen. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 1's impossible encounter deep in space today? We want to hear from you. Thank you for watching and see you next time.